Okay, in this lesson, we will be adding and subtracting radicals and then multiplying radicals. And this will include multiplying by distributing and using FOIL or the box method for binomials. So let me first start off by saying I'm sorry I can't be there today, but I wanted to make a video myself special for you because I did not like the way the video was explained from the one online. So I hope this helps and I hope you understand. At the top, it says when we add and subtract radicals, we have to do the following things. First, we have to simplify all radicals. And what that means is if you have a radical, a radicand, and it says something like the square root of 72, that can be simplified because the square root of 72 is the same thing as the square root of 36 times 2. And so that would become a 6, and then we would leave the 2 in the radicals. So if it says simplify all radicals, this is what it means. The next thing says that you are going to identify the radicals that have the same index and the same radicand because only those can be combined. What that means is the index, meaning the number that's on the outside of the radical sign, and the value that's inside of the radicand have to be the same. For example, the cube root of 6 and the cube root of 6. If you have the exact same radical, the exact same index, then whatever they have for their coefficient, meaning the number in front of them, okay, you would be able to work with as like terms. The last thing you would do, and this is just basically carrying over from the next step that we just talked about, is you would add or subtract the coefficients and keep the common radical. When I say this, I'm trying to get you to think back to when we did like terms, and we do it all the time. For example, if we have 2x and 6x, we would just add the coefficients and get 8x. Well, the same thing is basically true with these, except we would be adding the number in front of the radicand. Look at the example that I have right here that I just wrote. This has 2. This has a -6. You would just take the 2 minus 6 to get -4, and then you would keep the radical that has the cube root of 6. That's what it means when it says add and subtract, or add or subtract the coefficients. For number 1, we need to simplify the radicals that we can simplify. Both of them can be simplified. So I'm going to start with the 27. Recall, we have to leave what's on the outside alone. In my first step, all I'm going to do is break this apart, okay? So the square root of 27 becomes the square root of 9 times the square root of 3. And now I need to bring this down as well. And I'm going to simplify this. It splits apart to be the square root of 4 times the square root of 3. From here, I come over and take the square root of 9. It becomes 3. But there was already a 3 here. So the 3 times the 3 gives me 9. Bring down the radical, and you're done with that. Now come over to the next one. This becomes 2. The square root of 4 is 2. So I'm going to multiply 2 times the 2 that's already here, -2 specifically, and that's going to give me a -4. From here, I just bring down the radical 3. From this point, you have like terms. You have 9 and you have -4. They're both attached to the same radical with the same index. All I need to do is subtract the 9 and the 4, and I would get 5. And then I need to leave this alone, the radical 3. And that's it. Number 2. Alright, this time I've got a little bit more simplifying to do. You're going to want to look at your cube roots at this time because my index is 3, so that means I'm going to be trying to find the break apart for perfect cubes. First, I see that there is a 3 already sitting here minding its business. I'm going to bring it down. Now I know I need to split this. This will now become the cube root of 27 times the cube root of 2. And that came from me splitting apart the 54. Now I want you to bring down the negative 2 and then times the cube root of 2. I cannot do anything with this. There's nothing I can split apart in that radical. Now bring down the positive 7. And now I'm going to split apart this because this here can be rewritten as the cube root of negative 8 times the cube root of 2. Now I'm going to get the simplifying from each portion. This here, cube root of 27 becomes 3. And 3 times the 3 that's already there gives me 9. Leave this in the radical. So it's the cube root of 2. What you see from the next portion here is just a negative 2. And then this portion stayed the same, the cube root of 2. And now come up here and I want to simplify this. This will give me negative 2. But this negative 2 is going to be multiplied by the 7 that's already there to give me 14. From here, I simply bring down this portion. Now I see they all have the same radicand. Cube root of 2, cube root of 2, cube root of 2. When that happens, all I have to do is to add or subtract their coefficients. And my coefficients here are 9 minus 2 minus 14. 9 minus 2 is 7. And 7 minus 14 is negative 7. And leave the radical alone. Ooh. Number 3. For this problem, I need to look at the fourth roots. Okay, and let's do some bringing down and let's do some simplifying. First, I want to bring down my 7. And now I want to split this because the fourth root of 48 is going to become the fourth root of 16 times the fourth root of 3. And now this I simply bring down because I cannot do anything with it. Bring down your positive 3, but then this will be split because this will become the cube root of, oh, hold on, I need to make that look like a cube root. I guess that's better. The cube root of 9 times the cube root of, oh, I put the one that wasn't perfect first. I'm sorry. Let me fix that. It is the cube root of 8 times the cube root of 9. I know it's the same thing. I just like to put the one that is perfect first, because that's the one that's going to come out of the radical and multiply by what's already out of the radical. So come over to here, and this, okay, the fourth root of 16 becomes 2. Multiply this by the 7 that's already here, you get 14. And now I need you to bring down the radical. If you'll notice here, I've got a negative 2 for the coefficient, and I need to bring down the radical as well. And now here, this becomes 2. And the 2 will be multiplied by the 3 that's already there, giving me a positive 6. Bring down the cube root of 9. Okay, so I multiplied those, brought this down. I simply brought all of this down, multiplied this, and then I brought this down. From here, I want to look for the same index in Radican, which means I've got these two here. Take 14 minus 2 to get 12. And let's leave this alone. And there's nothing I can do with this portion here except bring it down. And you're done. Okay, we're not doing 4, so let's jump down to number 5. Let's see, we can do 5 or 6. Let's do number 5 because I like the variables on that one. For number 5, I have an invisible index, and that invisible index is 2. So this means when I separate this, I will have the square root of the following things. The square root of 49 times the square root of 2. And now let's look at the variables because we need to find multiples of my index. Is 4 a multiple of 2? Yes, so x to the 4th comes here. Is 2 a multiple of 2? Yes, so y to the 2nd comes here. There is nothing that goes into this portion right here because all of this was moved into the first radical. Now, I'm going to go ahead and simplify this. And this here, when I do the square root of 49, I get 7. And let's zoom in so you can see, so I can see if you remember how to do the variables. You're going to take that index of 2. I need to make that thinner so you can see. Take the index of 2, and it's going to divide both of these. So that will give me x to the 2nd power, and then just y. And I'm going to bring down the radical 2. Now let's get to this one here. Notice there is nothing I can simplify. So I'm just going to bring it down. Do they have the same radical? Yes. Have the same index? Yes. So all I have to do is subtract the coefficients, and that means I'm going to have 7x. Oh my goodness. I'm going to have 7xy minus 3xy. I said xy, but I meant to say x squared. And 7 minus 3 is 4. And I'm not going to add my exponents or subtract my exponents. I'm going to leave them alone. And I'm also going to leave this alone in the radical. And you're done. For the next section, I didn't mean to zoom that far out. We are multiplying radicals. When you multiply radicals, you're going to work different than when you add and subtract. Because when you add and subtract, you want to first simplify your radicals and then proceed to combining like terms. But when you multiply, you want to first multiply using the product rule and then simplify the radical. So multiply your coefficients, those are the numbers on the outside, and then you're going to use the product rule for the radicals. And what the product rule basically states is that when you have the exact same index, you can simply write that index down one time and then take what they had in their radicals and multiply them together in one radical. Once you get this value, all that is left is to simplify the resulting radical. Oops. Right here. Let's look at number 7. Zoom in. For number 7, I'm using the rule, the product rule, that states when I have the same index, all I have to do is write the index down one time, and we know if you don't see it, then it's an understood 2, okay? But what you see for the numbers are 27 times 5. Multiply these two together, and 27 times 5 gives me, I think it's 135. So now I have the square root of 135. And I want to see if I can simplify this. I need to know if it is divisible by anything that is a perfect square, because this invisible, well, understood index of 2 means I'm going to split this by a perfect square, the largest perfect square that can go into 135, which just happens to be 9. So I have 9 times 15, well, the square root of 9 times 15. The square root of 9, you know, will become 3, but the 15 will stay in the radical. The next problem, number 8. You want to multiply the coefficients this time, okay? The coefficients are 3 and negative 2. Let's look at that. You got 3 times negative 2. 3 times negative 2 is negative 6, okay? So 3 times negative 2 is negative 6. I'll write that down. But then you want to take the radical and multiply what's inside. So it would be 10 times 18. 10 times 18 is 180. So you're going to now split the 180 and see what is the biggest perfect square that can go into it. It should be 36 and 5. And now the 36 becomes 6. Well, let's not forget we are bringing this 6 down every step of the way. So when this becomes a 6, I'm multiplying it by the negative 6 that's already there. And this, of course, stays in the radical. So my final answer is negative 36 for the coefficient on the outside, and then the square root of 5 for the radical. Okay, we skipped number 9. Let's look at number 10. We got some fourth roots here. Now, your coefficient, you've got an invisible number here. So remember, your coefficient for this one right here is going to be a 1. And when I multiply my coefficients, I'm multiplying negative 3 times negative 1. Negative 3 times negative 1 is positive 3. And then I've got the fourth root of 64 times 8. 64 times 8 is 512. Bring down your coefficient, which is this 3. And I want to split this and see what two values will 512, did not mean to write the 512 in there, be divisible by. And I see it's 256 times 2. And now the 256, okay, this will become 4. The fourth root of 256 is 4. And then I've got to multiply this times the 3. And that's going to give me 12. But then y'all, we just bring this portion down. And we are done. Alright, let's see on the back side what we have. Got quite a few problems to look at here, so let's get started with some variables at the top. Number 11. Number 11 gives us coefficients again, but then we also have a radicand with variables. So let me take this nice and slow for you. You're going to multiply the invisible 1 that's here times the 5 that's here. That gives me 5 on the outside. Then I'm going to do the square root of, and now let's take what we have inside. 6 times 8, and then x to the 4th times x to the 5th. Okay. Let's bring down the 5, and then we can multiply this out to get 48. And then if you remember, x to the 4th times x to the 5th is going to give me x to the 9th. Now I can't leave it like this, okay, because the square root of 48 can be broken down. I know this because 16 times 3 is 48. When you look at your variable, your exponent has to be a multiple of 2. Is 9 a multiple of 2? No. But I can extract 8. So that means I will put 8 here, and the remaining 1 will go here. Now from this step, I have my invisible 2 that will come and divide this 8. But y'all, you're still just going to take the square root of 16, okay? The square root of 16 is 4. This will become x to the 4th power. And don't forget, this 5 has to come down here and multiply itself times this. What you have in the radical stays in the radical. So my final answer is 20 x to the 4th times the square root of 3x. Number 14. Let's look at what we did in the last problem. We're going to do the exact same thing again now. You want to multiply your 2, which is your coefficient, times your 7 here. 2 times 7 is 14. But now I have a radical that I need to put together. Because what this is telling me is that I'm now going to have p to the 2nd power times p to the 3rd power times q to the 1st power times q to the 10th power. Alright, let's bring this all together. That is going to give me p to the 5th and then q to the 11th. You have an invisible index of 2. So I'm looking for multiples of 2 here. Now let's bring down this 14. And you know that we don't have multiples of 2, but we're going to get them. Because I can extract from this first one here P4. When I do that, there's 1 left over that goes here. From here, I can extract Q8. And what's left is going to be 3. Now all I have to do is take this invisible understood 2, divide these exponents here, and I'm going to have 14, I'm just bringing the 14 down, times P to the 2nd, Q to the 4th, and then in the radical, it's going to be P, Q to the 3rd. My final answer is 14p squared q to the 4th times the square root of p q to the 3rd. All right. Next we have the good stuff. Binomial examples. This deserves its own kind of section here, because with the binomial example, you're going to be doing some distributing when you multiply. And we're still going to use the product rule, okay? So stay with me. Start easy with number 15. And I need you to look very carefully, because we still multiply coefficients by coefficients, but we multiply radicands by radicands. So this is an invisible 1. This 1 times this 5 is going to give me a 5. And now I'm going to multiply this radicand, this 10, times this 5. And I get the square root of 50. Now I want to multiply this 1 times this negative 2. I get negative 2. And then I multiply the 10 times the radical 2. I get the square root of 20. Simplify what you have here, because they don't have the same radicand. Okay, we're going to need to simplify using the rules that we did on the front with adding, subtracting. This means I'm just bringing down my 5, and the 50 will split. It will now become the square root of 25 times the square root of 2. I bring down my negative 2. This will split. It will become the square root of 4 times the square root of 5. And now I have 5 times 5, because this is what that becomes. It's still on the outside of the radical 2. This will become 2. There was already a negative 2 here. Okay, bring that down. And it's still with the radical 5. So our final answer, we have 5 times 5, which is 25. And then this is times the square root of 2. And then you have negative 2 times 2, which is negative 4. And this is times the square root of 5. Are my radicands the same? No. That means I cannot proceed and do anything else. I'm going to stop right here, and I'm done. Now, all this multiplying with these arrows sometimes is overwhelming, and for that reason, I don't do FOIL when I have a binomial. You are welcome to do FOIL. Knock yourself out. I am going to do the box every time when I have a binomial times a binomial. So, draw yourself a box. Come over to this side. We need a 2 by 2. And on the top, I'm going to write 8 minus the square root of 10. On the side, I will have 3 minus the square root of 10. Let's multiply to get in the box, and then we will simplify. 3 times 8 gives me 24. 8 times this negative square root of 10 gives me a negative 8 times the square root of 10. This times this here will give me a negative 3 times the square root of 10. And last, pay attention to your signs here. You have a negative times a negative. That's going to give me a positive. And then you have this times this, which is going to give me the square root of 100. We know that the square root of 100 is 10. So what I have left for like terms is 24 plus 10, which gives me 34. These are also like terms. So that's negative 8 minus 3, negative 11. And I'm going to keep the square root of 10 in the radical. You are done. Okay. Let's see, next on the list is, here we go, number 18. For number 18, if you see an exponent of 2, that means I am duplicating this. I am taking 4 minus the square root of 5 times 4 minus the square root of 5 again. Come over to the side and draw your box. On the top, I write 4 minus 5, square root of 5. And on the side, 4 minus the square root of 5. Okay, I'm going to speed up a little bit when the multiplying. This will be 16. This will be negative 4 times the square root of 5. This will also be negative 4 times the square root of 5. At the bottom, it'll be a positive square root of 25. The square root of 25 is simply 5. Cross it out, put a 5. And now this means I have 16 plus 5, which is 21. And then this gives me two like terms. Negative 4. Negative 4 is negative 8. Square root of 5, and you're done. Okay, what's next? Number 20. For number 20, this is a doozy. I'm going to need you to really stay with me for this one. But this is our last one. We need a box once more. So draw yourself a box to the side. And put across the top, very carefully, your radical with x minus your radical with 8. Radical with x plus your radical with 2. If I multiply the square root of x times the square root of x, that gives me the square root of x squared. Well, y'all, the square root of x squared is just x. Underneath it, if I multiply the square root of x times the square root of 2, I have the square root of 2x. Over here, if I multiply this, I have negative square root of 8x. And then in the last box, I have negative square root of 16. You know the square root of 16 becomes 4. So I have negative 4 in this box. Let's take our like terms and bring them over here. Now be careful with this one. I need you to notice something what I got going on here. I know the x is just going to come straight out, okay? But these are not like terms the way you see them, because this has a 2x, this has an 8x. So I'm going to bring them over separately. Square root of 2x minus the square root of 8x. And then, of course, I'm going to bring over the negative 4. What can I do, if anything? Well, I see that I can simplify this radical right here. This radical will become the square root of 4 times the square root of x. Oh, I just missed the number 2. Sorry. Because 8 times, I'm tired, it's late. 4 times 2 is 8. The x is not a perfect square, so it comes in the leftover. And now bring down my negative 4. This here is going to become negative 2. And then it's times the square root of 2x. Bring down the negative 4. Bring down everything else in front of it. And now I have like terms. The square root of 2x, the square root of 2x. So that just means I'm going to add their coefficients, which is a positive 1 minus 2. Well, that's a negative 1 square root of 2x. Bring down the x here, and bring down the negative 4 here. This is your final answer.